Okay, so we in this today's session we will be continuing our discussion on machine learning. Today we'll be looking at what are the different types of machine learning, what are the different areas of application of machine learning, or what are the places where machine learning is helping us to improve the system, improve the efficiency, get more customers, or we'll look at all those things. Okay, so yeah, so first of all, what is the importance of machine learning, right? So all of you have visited this website. It is called Amazon. On the top, you will see recommendations for you. Like in electronics, if you have bought a mobile or a mobile cover or a power bank before, it will keep showing you that on the top, right? If you watch Netflix on the top right, or maybe Amazon Prime, so you get recommendations, right? So even me and my wife, both of us have Amazon accounts and Netflix account, but the recommendation for both of us is entirely different, right? So it is very user specific based on what kinds of content one person watches on the streaming service, the kind of searches he or she makes on that app, right? So all those things are being taken into account. Now it is just Amazon and Netflix and Amazon Prime videos, but suppose I have all other informations about the person also. So maybe like that person is a female or a male, what is her age, whether is she working somewhere or not, maybe because if she's on Amazon, I would have her or his or her transaction history. So I can club those with to give a better recommendation in the Prime section or the video section also, right? So maybe if one of the customers is buying a lot of Thor t-shirts or Marvel t-shirts, then of course that Amazon Prime should pitch more Marvel movies or superhero movies, right? Whether irrespective of whether he has searched or watched any Marvel or superhero movies on Amazon Prime also, but this can also be a feature. So in all those ways, machine learning or the data or the digital footprint that we leave on the web is being used in our favor to provide recommendations, to provide suggestions for what products we should buy, or what kind of content I should consume, what movie should to watch, what shows to watch. Okay. Next is machine evolution of machine learning. So machine learning is nothing new. So basically what I'm saying, you will get a in this green rectangle, you will get a kind of a subscript or a subtitle of whatever is there in the slide, right? So machine learning is nothing new. Actually, these concepts of machine learning and using data to get some patterns and making some insights out from it is goes around 70 years back or more than that, right? So we have statistics, we have probability theories, all that were there since a long time, right? So since 1950s we have research in machine learning. Then 1960s we have Bayesian methods. So Bayesian method is used till now. So we have Bayes theorem from probability in our schools. Around the 1970s there was a period called AI winter, because everybody was pessimistic or not very fond of machine learning. There are reasons, because there were no fast computers back then. There were not enough data, right? So if I want you to just tell me something about your friend, a friend of friend who you have never met before, so you have absolutely no data point about a person, so you cannot tell much about that person to me. Once you have spent time with him, you have known him for 10 years, then you can tell pretty much almost everything about that person, likes and dislikes, what kind of movies he watches. So similarly, back then we were not having this kind of infrastructure, we did not have computational powers, right? So during this is the time where this 128 MB of space was used to be was shipped in a truck, right? So a computer was as big as our house. Basic computer for a calculation plus minus multiplication, it was taking hours, right? So it was, all the concepts were there, the books were there. So if you delve deep into machine learning, if you want to read a text, you will find books dated back to these times, and they're still valid, right? So around 1990s, which is the time when we all of us are born, I guess. So this uh, that everything shifted from knowledge driven to data driven. Knowledge driven means I know a certain concept and I can program it. So an example can be, I'm making an app just like in Amazon. So I want to pitch, okay, if someone buys a t-shirt, I should pitch a jeans. So it's a knowledge, because I know if a person is buying a new t-shirt, he might need a jeans also. So I am programming a computer based on my knowledge of that particular thing, a particular scenario or particular system. It's a selling system or a e-commerce system. So it's called knowledge driven, but they shifted from knowledge driven to data driven. So you do not have any preconceived notions. You do not have any knowledge, prior knowledge. You just see, you just record that data, the kind of transactions, the kind of buying and selling behaviors people are doing on Amazon, and based on that only we will pitch something new, right? So in 2000s we have support vector machines, kernel clustering, kernel methods, all these things we'll discuss in detail, but they all appear in 2000s. And 2010 we have deep learning, right? So it became very common, and deep learning has become more common as of now because of the computational powers and the kind of huge data that we all of humans are generating. Not just humans, it can be a website, it can be a power plant, it can be an automobile factory, right? So everything is now connected to internet, right? So in 2010 I think I made my Facebook account, net was around 1 GB per month, 250 rupees, like that. And now you see it's every day 1.5 GBs, and it's costing us very less. Even the rickshaw pullers, the hawkers, they are using Bheem and UPI and Google Pay. They all have Facebook profiles, right? So we are creating and generating lots and lots of data these days. So that's why it is the evolution looks like this. Okay, now what are the benefits of machine learning? Okay, so one example is simplifies product marketing and assists in accurate sales and forecast. Okay, so basically we have now, since we have unlimited data, kind of unlimited data, you never know how many people are there on Amazon, how many people are buying from Alibaba or eBay, right? So we have a lot of data. We can figure out customer behavior patterns, we can modify our strategies, we can train a specific model, and we can get some focus data, right? So there are a lot of junk. So like maybe your phone number is important, but your phone number does not play any role in what kind of things I should suggest for you, right? So it's just a thing, I can drop you a message or I can communicate when the order is placed or not. But in general, the phone number is not a feature which can define any buying capacity or a pattern, right? So one thing is, for data crunching, we are also using machine learning, right? So maybe the location coordinates are not important for suggesting what kind of a movie a person should watch, right? Once I know he is in India, then I will prefer more Indian movies over international movies, and later on, if the person is consuming more of the international content, I can switch over my strategy. So this is one way of in which machine learning is helping all of us, right? Maybe just change it to screen share. It will now get off. I'll just share my screen again. Okay, now I think it's fine. Okay, next thing is next benefit of ML, right? So I have unlimited data. I can just I have unlimited data. I can optimize that data to give me a best offer. So until recently, like the offers on Amazon, Flipkart, Myntra, all were quite common, and it is quite common during this time also. But there is one major improvement, is that where we get offers based on our individual accounts, right? So if you are getting an offer of 50% off on something, it is not necessary that I should also get that offer. So based on an individual performance on the website, we are getting offers and these coupon codes, like individual targeting is being done. Because now I have the infrastructure to record all that data. I have infrastructure, these companies, they kind of have an individual digital profile for each of the individuals or the customers, right? So they can group similar customers together also, right? So if suppose you can think of, if a person who is earning 1 lakh per month, so any person who is earning around 60,000 to 1,20,000, all of them, their expenditure is going to be more or less same if they are living in the same city, or if they are living, all of them are living in metro city. So all the persons who are earning around 1 lakh per month and they are living in a metro city, then their kind of expenditure pattern is more or less similar, right? So we can group them together. Next is you yeah, so better, so it's the same thing which I explained before. So we have interpretation of past customer behavior, right? So based on that, so if a person is buying certain things only when an offer is given, then we have a pattern that, okay, we have to give him offers to make him buy more. Okay, or if a person is just doing recharges, so should I give him an offer like that? If you do a recharge of 250 rupees, you get a 100 rupees off on t-shirt, so that I can make him intentionally move from just recharges to buying a product, right? All that can be done. Next is it facilitates accurate medical predictions and diagnosis. This field of medical imaging and medicine and healthcare is becoming a very big opportunity where machine learning and this computer vision and deep learning are being deployed. Okay, so just think of a example where all of our family members and all of our friends are having a record of their medical history at their respective doctors or maybe with them. Just like a Facebook profile, all of us have our health profile. So when I was 2 years old, I got this kind of vaccination. When I was 5 years old, I got chickenpox. When I was 8 years old, I get this kind of some rashes on my body. Then I was given these medicines, and after 5 days, I was fine. So if I have, suppose for individual, each and every person, we have this kind of a digital record, then this diagnosis and prediction of kind of allergies and what kind of disease a person may fall into, it becomes very easy, right? And we can also extend this thing to, suppose you got maybe a cough and cold. I have three medicines ABC. I gave you B. It took you 15 days to recover. And then next person comes, he also had cold. I gave him A, and he was fine in just 2 days. So we can also try out what drug is doing better. So is the drug itself is better, or maybe it's the person's body how it is reacting to the drug, right? So all that information can be very easily consumed in a machine learning framework, right? So patients records and symptoms of the patients and improve healthcare with minimal cost, right? So we don't need to change our family doctors if I have a record history. So for me individually, like this, keeping a record of all the doctor visits and all the papers that we get from doctor's end is very difficult, right? So we need to physically store them in some storeroom or that, but it is not good. But once you do change city, change the doctor, it becomes difficult for the doctor to diagnose. So yes, so it happens when you go to a doctor, the new doctor, he may take at least 1 or 2 weeks extra to solve your problem, right? Because he is trying different kinds of drugs and medicines which may work on you or may not. But after a week of, he will say, come back after a week, he will then diagnose, okay, this medicine is not working. He will change something, and maybe after 2, 3 or 4 weeks, you will get fine. So all this time can be reduced if we had this digital record, and we have a model in place, right? So I think for very basic problems like cough and cold, all of us just Google it and take that, okay, take the cold total or take Vicks Action 500. So we can actually create a very simple model or an app where, based on my symptoms, putting my symptoms and my record, the algorithm should give me, okay, you take these medicines. So with medicines, it can also give, okay, you drink more tea, you avoid non-veg for a while, or avoid oily food. So all these we can actually do this, because if you look at all your doctor visits, most of them are kind of similar only, if you are not suffering from a very dangerous disease. Okay, next thing is data entry. So previously, before machine learning time, all this data entry was a big hot job. Okay, so we need people who will keep a record of all the data to keep. So in a shop, you buy a product, then that one person needs to be there who will enter, okay, this product is sold of this much, the bill number is this, all that things are being there, and it should remove it from its inventory. Right now, all this data can be automated. We have QR codes, right? If you go to a Big Bazaar or Vishal Mega Mart, they will just scan the product and tuck, you will get a bill, everything, invoice number is generated. So we did not have POS in 2010 or 2005, right? So with this advancement and improvements in technology, we are having all this. Okay, next is improves precision of financial rules and models. Okay, correct. So banking for most of the people is just a place where our money will come in and we will take out whenever we need it. But in general, the financial sector is very broad. So there is a lot of trading, share market is there, investments are there. You can put your money so that it becomes double or like that. So all of that, all of these things are normally done by humans, right? So there is a manager or the fund manager who is looking at tracking all the different high performing assets. So maybe Reliance Oil is doing good. Then now it's a time of electric vehicles. So any energy company which is in electricity or in automobile can perform really well in next few years. So all those is done by human. So if you have seen Zindagi Na Milegi Dobara, that Hrithik Roshan, his intro scene was there. He was in a big stock market and he was watching a big screen full of data, Sensex and all that. And he was saying, sell it or buy that, all that. So all these things are now can be done using an algorithm. So because an algorithm is, or a computer is much smarter at memorizing things, keeping a track of previous data, right? So if I told you what I told in the last month of same day, what topic did I tell you? So it will take some time. Maybe you cannot recall at all, but a machine can easily do it, right? So same things now we are having portfolio management. Means portfolio is in an individual person's money, where to invest all that. So where all the places where I'm investing any one person's money is called the portfolio for that person. Algorithmic trading. So I'm doing share trading, but based on an algorithm, right? Then we have loan underwriting, fraud detection of analysis and anomalies and nuances. So on a bank, on a general day, you have lots and lots of transactions, some money going from here to there, some money is being paid to any customer, or to the most of the money is being paid to a company. Like if you're buying on Amazon, if you're doing a payment to a vendor. So these transactions are normal, right? So but there are huge in number. So just to keep a track, like these are genuine transactions and not fraudulent transactions. Either I can keep a person who should keep looking at all the transactions every day. He may take 2-3 years to figure out, okay, at 4 years back this thing was wrong, it was a fraud, right? But when I have an algorithm, it can just very quickly check, okay, this transaction is okay, it belongs to this thing, it's normal, or it's not, it's just a routine transaction, or it's a fraud transaction. Okay. So if you, I don't know if you have, but if at my friend's sister's wedding, I took out 40,000 3 times a day from my account, which was transferred by my friend. So I say within 5 minutes I got a call, sir, this transaction is done by you, or is it a fraudulent transaction? So basically there is a system which was monitoring my account. So for the last, in my history of that account, never this big amount was taken out once, but today it was taken out thrice in the same day. So maybe some algorithm or some program alerted them and asked them to call me or whatever, right? So all these things are being made easier with the use of machine learning, right? This thing is very simple. In our email, just open your mailbox, you will find something in the spam folder which is already spam, and you will find lots and lots of mails which are spam, but they are in your inbox. So that thing, so this concept of differentiating between spam and not spam emails was done by a deliberate effort of individuals like you and me, who marked their mails as spam or non-spam. So you can put a label on your emails, it's a spam, it's a spam. So next time whenever any mail similar to that one come, it will by default go into spam, right? So it's just a example of supervised machine learning, right? So this is spam, this is not spam. So next time so it's like I'm telling a person, this is hot, this is not. So if it is hot, the child should not touch it, right? Okay, same thing. Next is so this is kind of what I used to work on till my MTech. So this is what increases the efficiency of predictive maintenance in the manufacturing industry. So now just like your bike needs maintenance, so after every month or so in a month you need to take care of that. If you're driving your bike daily, you need to take care of the tire pressure, the petrol, and you are kind of very well versed with what kind of vibration or noise your bike is making, right? So bike is just a small piece of machinery, and it requires its own maintenance schedule. You should not park it in the sun, then rain, then sun, it may corrode it. So think of a plant, very huge plant which is static, and it is undergoing rain, all the seasonal changes throughout the years, and it has lots and lots of interconnected smaller parts, right? So there, this concept of predictive maintenance, it has a very specific value. So we have a specific department in these plants, power plants, automotive industries. In any big factory, we have a specific department whose job is to keep all the machineries running and in good condition, right? But a machinery has lots and lots of parts, so keep a track of each and every nut and bolt and every piece is very difficult if you do it manually. So it's better to record the complete maintenance activity, any breakdown that might have happened or any remedy that we tried to solve that problem on digitally or maybe manually. They are presently recorded manually, and some companies are doing it digitally also. So based on the previous experiences of failures and breakdowns, we can predict, okay, this thing, okay, so after every 3 years this part fails, it needs to be replaced. So like, what can I plan is that, okay, after every 2.5 years, just go there, maybe do a servicing of that part, put more oil or do a repaint everything, right? So such kind of activities I can plan if I have a database, and I can also put up a design an algorithm which can do it for me, right? So we have this preventive. So there are different types of maintenance. Predictive maintenance is to predict when something is going to happen. Preventive maintenance is what we do on our bike. So we do not wait for our bike to just seize in the middle of the road, but we keep cleaning it and keep putting air and putting oil and keep servicing it at a fixed interval. That's preventive maintenance. Corrective maintenance is when something bad happens. So you went there, your engine seized out, and now you have to take it, call a guy who will come here and take your bike and make it work. That's something. Corrective maintenance is when something wrong has happened, in order to correct that whatever you are doing. So the best thing is, the highly efficient thing is predictive maintenance, right? So before anything happens, I know this is going to happen and I am taking measures before that, right? Prevention is better than cure. Same concept. Okay, next is machine learning helps us helps in better customer segmentation and accurate lifetime value prediction, right? So life insurance companies, e-commerce companies, so they mostly rely on their customers. So they use something called digital driven data driven marketing. We have data, we have their website visits and their visitors, we have different kinds of email campaigns. Okay, join this workshop so that you can be a get this membership, all that. So based on all this data, I can divide my customers into three segments: high potential, medium potential, low potential. High potential means like they are very likely to join our campaign or buy our product. Medium ones are okay, they are okay. Low potential are the ones where, okay, they are not interested in our thing. So my strategy can be to get more of these, maybe do something which so that I can attract more low potential customers, and I need to retain all these two, right? So something I can pitch to my manager or my team, where we all of us can talk out about a strategy to do, right? So this segmentation from this data is given by because the customers are going to be in crores, right? In crores or maybe more than that, millions and billions. Okay, so the classification of customers into these three based on their buying potential is done by an algorithm, and the strategy we can make based on a discussion or based on our understanding, right? Next is machine learning recommends the right product. Okay, so this has become very common right now. Okay, so if you have for me, every month, at the end of the month, you have to do this recharge. All the free charge, MobiKwik, Google Pay, they will tell me, okay, now you have to pay the bill for this phone number, now you have to pay the bill for this phone number, your electricity bill is there. They keep reminding me. So this is very simple thing. They can be done logically also, right? Because these bills are need to be paid monthly basis. So we can just write a simple program to reminding the user. But suppose you bought a pen and it runs out after some time, so it will be really cool to see that Amazon gives you, okay, after 2 months, okay, your pen is running out of ink, please time to buy a new pen. Okay, or maybe you buy a mobile phone cover today, and after 6 or 7 months the Amazon pitches you, okay, it's time to buy a new mobile phone cover, and of course after 6 to 7 months your cover might be worn out, and based on the phone I'm using, based on the IMEI number, the website knows, okay, it is the same phone which he was using 6 months back. So all these things are being digitally tracked. So we can, based on our purchase history, we can give recommendations and we can like top picks for you, right? So suppose if I'm looking for something under 1,000, and with a branded product under 1,000 which should have some offer also, so the algorithm will pick the best products for you and will show you on the screen, right? Then we have so basically, like, this is all example from a Gmail account. It's a Facebook account, right? So in Gmail we have spam and non-spam emails, right? In Facebook, if you nowadays if you post a picture, Facebook by itself will tag or give you, okay, tag this person by doing facial recognition, right? So just like we saw yesterday, we can do facial recognition also very easily, right? Because now if I take a picture, take a picture of random person and just check it through the complete database of Facebook, so it's very probable that I will find that person, or maybe I will not find that person if he's not on Facebook, which is very rare. Everyone is on Facebook. Next is so this application of machine learning in the stock market is pretty simple, because it generates from the fact that a machine can crunch a lot of data. It can work for longer hours without any breaks. It does not need food, it does not need rest. But whereas a person needs to rest, he can only work to a 9 to 5 job, or maybe he can work more than that if he is hungry for money, but he cannot do it for a longer period of time, right? So health need, requirement of food is all something related to humans. Okay, so it says the meeting will get over. We'll maybe start a new, otherwise we'll wrap up in this one only. Right. So next example is that any payment, genuine transaction or fraudulent transaction. So it's just an example from different company called PayPal by Elon Musk. Okay, so he was the first one to solve this problem of visiting to banks and doing the transaction manually. He came up with this digital transaction thing. Okay, so we can differentiate between genuine and fraudulent transactions. Okay, now moreover, if the general term analytics is to maybe research, or based on some data that you collected, come up with some kind of a strategy, come up with some outputs. Okay, based on the data collected, these are the findings, and these things are going to happen in future, and these things we should do in order to be prepared for the future, like this, right? So at the core of analytics we have machine learning, and what we mainly do is predictive analytics. What mainly companies does is predictive analytics, right? So from past historical data to research potential trends, to analyze the effects of certain decisions or events, or to evaluate the performance of a given tool or scenario, right? These are the things that we can do based on the past data, and ultimately what our goal is to improve the processes by gaining knowledge. This is what analytics is. There are three types of analytics: descriptive, predictive, and prescriptive. Okay, so we will look at all these. So there is descriptive analytics, prescriptive analytics, and predictive analytics. So as the name says, they are kind of very simple to understand, but they play a huge role when we do this in a company or a product, right? So descriptive analytics is what has happened, summarizes the raw data and makes it interpretable by humans. So descriptive analytics is, okay, you went to a doctor, okay, so you have this disease because you have this cold because you got drenched in rain and you ate ice cream after that. So it is descriptive what has happened, right? So basically we use data aggregation and data mining techniques. So data aggregation and mining is that we are collecting data from different sources, and based on that I'm doing some processing. Yeah, right. Next thing is predictive analytics. So predictive analytics is what could happen. Right now, predictive, if you went to a doctor and he says, okay, if you continue eating ice cream and getting drenched in rain like this, maybe at some point you may lose your voice. Maybe your vocal cord may get destroyed, or you will get tonsils or something like that. He can tell you. So this is what could happen. So based on the data and understanding, I can use statistical techniques and models to forecast what can happen in future. Right, it provides companies with actionable insights based on data, right? So think about 1 year back when COVID was not there and suddenly COVID came. So during the initial few months of COVID lockdown, it was becoming evident that all the things are going to move on to online, Okay, schooling will be done online. All that buying and shopping, all this logistic delivering things are going to happen online. So if the companies were prepared for this thing in 2018 or 19, our life could have been made more easier. We could have more cheaper phones, or we could have tablets, we could have better internet services being provided to all the parts of the country. So till today, we have some places, some villages where we do not have electricity, where we do not have internet. So they are still dependent on school, going physical schools to get to study, right? Then prescriptive analytics, that means what should we do. Prescriptive analytics comes from the word prescription, which means like what. So now, since you went to the doctor, you have cold because you ate ice cream. Now what can I do is I can give you a medicine. You do gargle every day, twice a day. You drink more tea, and you take these medicines. This is what I can do in order to avoid this situation, right? Suppose, think of another thing where this thing is for our benefit. So you went to a doctor and you found out, sir, my shoulders are growing big, and I don't know, in last just 1 month my height has increased by 1 centimeter. So he will perform some tests, and he will say that it's really good, that it's great, because you are at that time, you are at that point of time where your muscles are growing very fast. So I would recommend you to work out more, so you have a better shape, right? So the prescription or the descriptive analytics can give you any problem it can give you which you want to avoid in future, or it can give you any good point which you want to capitalize upon, right? So both the things. So mostly it is done for capitalizing on the good points if used by a company, right? So basically, it attempts to quantify the effect of future decisions in order to advise on possible outcomes. Uses optimization and simulation algorithms to advise on possible outcomes, right? So basically, it is to give the advice to the users on what actions to take. This is what it is. Next is so this trend we have seen yesterday, this trend of machine learning, right? So I have an input data, then I have a machine learning algorithm, I'll get predictions, and machine learning algorithm will give me predictions only by training. So I have lots and lots of examples. I will train my machine learning model, and then I can use it to make predictions for a new data which it has not seen before. Okay, so just a general idea difference, or not a difference, we have artificial intelligence, we have machine learning, we have deep learning. So what is the difference? So artificial intelligence is the general term, right? So probability statistics, everything is mathematics, right? So if I say everything comes under mathematics, so just like an umbrella term or a bigger picture is artificial intelligence, making systems, making machines, making cars smart, making a refrigerator smart or intelligent. It comes under the purview of artificial intelligence. Inside this, I have different techniques for machine learning which can apply to specific datas. And if I'm talking about some text or audio data, then there is a different zone which is called natural language processing. This is also a subset of machine learning only. So they are kind of overlapping, machine learning, artificial intelligence, and deep learning, right? So what is, I will call something artificially intelligent if my game, there is a game which can play, I can play chess with it. There's a computer, I have Alexa, I can talk to Alexa, it will give me answers. There is a self-driving car. So all of these things are artificially intelligent, but in some way. So Alexa is using NLP, right? This thing, self-driving cars are using machine learning and computer vision and lot more to make decisions how to drive a car. And this thing, playing a game of chess also requires uses machine learning, or it's kind of a rule based program, but it is intelligent, right? Now there are different types of machine learning. So maybe I'll just drop this call and we'll start a new one because it's a new topic. Okay, so just join back in maybe like 2 minutes. I'll share a link. Okay.